Hi, I'm a turtle hugger. I love sea turtles, and so do many people around the world. And because of that, we've turned them around from the brink of extinction in just 1 to 2 generations. I'm also a self-confessed and slightly proud of it, a turtle geek, and I've been researching them for 25 years, and I'm going to give you some glimpses into the things that we found out, focusing on the green turtle. So this is Ellie. Ellie is a green turtle who was born in Ascension on the 12th of May, 1969. Means she's 48 years old, just like me. She's called Ellie because that's my daughter's name and she'll hate that I've done this. Ellie emerged with her brothers and sisters from a nest on Ascension Island all those years ago, but mostly sisters, because the gender of sea turtles is determined by the temperature at which that they are incubated, and the vast majority of hatchlings are females. So I'll just leave you with the thought of what will be the impact of climate change-related global warming on sea turtles if the babies are already 90% female and the temperature's rising. The hatchlings dig their way out. They find the sea by going to the brightest horizon, and then all together they make a run for it, and they head for the open ocean, trying to swamp any predators that are waiting for them on the beach or in the nearshore waters. At that point in time, however, Ellie is now all alone. She heads out into the open ocean, and for 3 to 5 years, she's away out there, hiding in the open, because predators are more concentrated by the coast. It's harder to find her out in the open ocean. So she's out there at the behest of ocean currents, eating small planktonic organisms. And after 3 to 5 years, she moves into a seagrass meadow. And because Ellie was born on Ascension Island, that could have been on the coast of Africa or on the coast of Brazil. She then perhaps moves on to an algal bed, definitely in Brazil or Uruguay, where she feeds on algae and perhaps seagrass. And it's the greenness of the food that taints the color of the fat, and that's why green turtles are called green turtles. Not because they're green on the outside, they're green on the inside, like many of you, I hope. She eats her greens, and then during this coastal phase and also in the pelagic phase, this is a period where these young naive turtles are exposed to ever-increasing burdens of plastic, which look like food. And this is 155 pieces of plastic that was taken out from one juvenile turtle in the Mediterranean. And this is I'm going to tell you good news in this talk as well, but this is something that we should all be concerned about, the impact of plastic. Also, this sad picture is a turtle's eye bathed in crude oil. This is a victim of the Deepwater Horizon spill in the Gulf of Mexico. And again, other forms of pollution, if we don't get a handle of them, are going to degrade our marine habitats and our marine biodiversity and impact our health. So we do need to look at these things too. But in these series of foraging areas for about 20 years, Ellie grows up to a point in time where she starts to feel like it's time to move on to the next stage. And that's when the hungry swim begins, because she swims all the way from Brazil to Ascension Island. Ascension Island's in the middle of the Atlantic, halfway between Brazil and Africa. It's maybe a swim of 2,000, 2,500 kilometers, takes her over 6 weeks, and she doesn't eat from when she leaves the foraging area. When she gets to the breeding area, the males are already there waiting, and so there's mating. Males are actually smaller than females in sea turtles, so that they're agile and they try and outcompete each other for her attentions. She'll often mate with more than one male, and then she'll find somewhere to hide out for a month while she produces her fertilized eggs. After that month, she'll start coming up the beach to complete the cycle. And she may be coming up on the exact same beach to which she was born, but certainly to the same area where she was born. She will lay at probably 3, but usually at least 5 clutches of eggs at 2-week intervals, 120 ping-pong-shaped eggs, about 1 meter in deep. And then she'll cover her tracks to try and hide the nest from predators. So if we just think, then once she's finished her clutches, she heads back to Brazil. 6 weeks coming across the Atlantic, mating, a month waiting, 10 weeks of producing eggs and laying eggs and digging holes and covering over, 6 weeks back across the Atlantic, 6 months not with a bite to eat. She lives off her fat, and perhaps not surprisingly, green turtles don't breed every year. They take a couple of sabbatical years in between and try and feed up before they do it again. But this life cycle, avoiding predators, swimming across the oceans, has been extremely successful. These animals have been around since before the dinosaurs. It's a really successful life history trait, and these animals have persisted in large numbers at some points in time. As Europeans colonized the tropical world, these animals were in an abundance and were harvested ruthlessly. They were there, they came every year, they could be kept alive on boats, was fresh meat for a long time, and so many populations were extirpated within an inch of extinction. But with a conservation ethos developing in the 20th century, lots of conservation started to happen, and many populations are starting to recover. This truckload of turtles was recovered in North Carolina last winter. There was a cold snap, and sometimes in the northern part of the range, they just get too cold and just wash up on the beach. But these green turtles are existing in numbers higher than ever recorded in historical times in North Carolina because of the conservation that's going on in Florida and Mexico. Because these are animals that live without international boundaries and they move across ocean basins. Also on the nesting beaches, many populations are starting to increase. There are threats, however. We're still concerned about fisheries bycatch, accidental capture in fisheries, and because there are less fish around the world, more fishing happens to catch them, which means there's more chance of catching turtles, and they can be caught in long lines, in trawls, in gill nets. And so what we really need to do is know where the turtles are living, where the fisheries are at, and look at where the hotspots of interaction are so we can mitigate. This is a younger me, 25 years ago, tagging a turtle in Cyprus. That same turtle is still coming up to breed every couple of years. She's probably also, like me, 48 years old. We can tag them, but it takes an awful lot of time before you start to build up the information of the movements, and you're dependent on people reporting it, and you don't know what they did between one flipper tagging and its recapture. You don't know what the turtle did in between. So with the advent of satellite telemetry, we're able to look at this big ocean from space, and we can know where our tagged animal is from the moment we release her on the beach till the moment she turns up in the foraging area. And so this isn't Ellie's population, this is in Cyprus. This is a satellite transmitter. And so it just basically pings up to space. The satellite tells us where she is, like a GPS. We can download it and create maps of where she is. So we tagged 30 turtles in Cyprus and Turkey, Israel and Syria. And you can see in the map behind, the redder the areas, the more turtles that pass through. So we can start to create corridors of where these animals move on migration. Also, the black dots with the numbers in, those are foraging areas. And you can see that different numbers of turtles are in different areas, but they're discrete areas. And so now we can zoom in on those two areas in Libya and see what can be done to preserve half of the population of eastern Mediterranean green turtles. Some of our tags also have really cool dive computers on board, and so we can start to get insights into what they do, where they are. And so if we just look at the top graph here, time goes along the x-axis along the top, so we've seen a 24 hours in the day of a turtle. And in the summer, in the top graph, you can see she's diving to about 25 meters for about half an hour, up for a breath, back down, foraging away. Still pretty good for breath hold diving, half an hour whilst active, all day, all through the night. However, in the winter, when it gets cold, the seagrass has stopped to grow in her foraging area, and she does considerably less. She sits on the bottom, 6 hours, has a breath, back down, sits on the bottom, has a breath, 6 hours. What did you do today? I breathed 4 times. So this animal isn't hibernating, but to all intents and purposes, she is. She's sitting out the winter until she can start to feed on the spring flush and then hopefully go back and breed some more. So hopefully I've started to turn you into turtle geeks, and maybe some of you will be even slightly more turtle huggery than you were to start this talk. What about Ellie? She was born in 1969. She moved to Brazil in 1974. In about 1994, she started migrating to Ascension and breeding every 2 to 3 years. It's October now. The breeding season begins in November. So right now, she's in the middle of the Atlantic, swimming to Ascension, starting to feel a bit peckish, but she's on her way home. Thank you very much.